Impacts and collisions 2015 question 5b. Two identical spheres, P and Q collide. The coefficient of restitution is 1. Velocity of P before impact is AI plus BJ and Q CI plus DJ. I is along the lines of centers, and we'll see that in the diagram. After impact, the motion of P makes an angle alpha with this line of centers, and Q an angle beta with the line of centers. Show tan alpha tan beta is BD over AC, and we are given the following diagram. So we start with our principle of conservation of momentum. M1U1 plus M2U2 is equal to M1V1 plus M2V2, and we know when I is along the line that I is going to change and J is not. So let's fill that information in. They're identical spheres, so we can call M1 and M2 M, and U1 in this case is my A plus M by C is equal to MV1 plus MV2. So MA, well, we'll cancel our M's. A plus C is equal to V1 plus V2. So if I use Newton's experimental law, we're told the coefficient of restitution is 1 in this case. So we have V1 minus V2 over U1 minus U2 is equal to minus E. So V1 minus V2 is equal to minus 1 times U1 A and U2 C A minus C. V1 minus V2 is equal to minus A plus C. And we also have, from here, if I bring it down, we have V1, not a plus, V1 plus V2 is equal to A plus C. So we're going to get 2V1 is equal to, well, the A's as well cancel, 2C. So V1 is equal to C, which would mean that V2 would have to be equal to A. So if I write down their velocities after, for P, it started with AI plus BJ. So the velocity for V1 has changed from A to C. So we're dealing with CI plus BJ. The J's isn't going to change. And for Q, the C has turned to an A. So we're dealing with AI plus DJ. And this one is alpha and this one is beta. So the tan of alpha is B over C. The tan of beta is D over A. So tan alpha tan beta is equal to B times D over C times A, and hopefully that's what they were looking for. BD over AC or CA, same thing. So quadratic demonstrandum, you have demonstrated, which must be proven.